This video is part of an online course of multivariable calculus, and I'm going to talk about polar coordinates. So let me start. We represent a point in the plane by an ordered pairs of numbers. So an ordered pairs of numbers is called coordinates. So we show a point on the plane by some coordinates. We are familiar with the Cartesian coordinates. Cartesian coordinates, and what they are basically this. So if I have a point in here in the plane, this is x-axis, this is y-axis, then we calculate the distance of the point to the x-axis and to the y-axis, and the distance of the point to the y-axis we're going to call it x, and then the distance of the point to the x-axis we're going to call it y, and this is x, this is the y coordinates, and we call it the Cartesian coordinates, which is what? Which is the distance, actually the direct distance of the point to the perpendicular axis. Okay, so this is the Cartesian coordinates. We have another coordinates that we call it polar coordinates. And polar coordinates is also a pairs of numbers, and it was introduced by Newton. And it's what? We pick a point on the plane and we call it the pole. We usually use the origin for that. We show it by O, and then we have a horizontal line that is corresponding to basically the positive x-axis, and we call it polar axis. Then any point, for example, any point like this point, I'm going to call this point P, we use two numbers, a pairs of numbers to show the coordinate of this point. One of them would be the distance of the point to the pole, to the origin, we call it R, and the other one is the angle from R to the polar axis, which is basically the positive x-axis, we call it theta. So we have a pair of numbers that we show the point by this. On the y-axis we have the same idea. So if we have a point like this in here, we're gonna use two numbers. One of them would be the distance of the point to the origin, and the other one is the angle from the positive x-axis to the R. We show the point by that. So what is R? What is theta? R is the distance from the point to the origin, and theta is basically the angle between R and positive x-axis. It should be counterclockwise, and it also needs to be in radian. So it should be like this angle. Okay, very good. Let me have some examples. For example, I'm gonna show the point 1 and pi over 4. Since I have a radian in here, it is not the Cartesian, it would be in polar. And if I want to show this point, I'm gonna use x-axis, y-axis, then 1 would be here, and the angle would be pi over 4, so I'm gonna go on here. Okay, so this is the angle is pi over 4 counterclockwise to the from the positive x-axis to the distance r. R here is 1, so this point in here would be the point 1 and pi over 4. Another example would be the point, for example, 3 and pi over 2. And what is this one? X-axis, y-axis. This is the origin, 1, 2, and then 3. And the angle is pi over 2. So from the positive x-axis, I need to kind of measure the angle pi over 2, which would be right there. So 1, 2, 3. This is this point, the point 3 and pi over 2. Okay. And another example would be this point. For example, 2 and 3 pi. Where is this point? Okay, this is the point in polar coordinates because I have a radian in here. So I'm gonna count 2 as the distance r from the origin, 1, 2. And then I'm gonna count 3 pi. So this is 1 pi, 2 pi, and then 3 pi would be here. Let me have the negative x-axis as well, and actually let me have the negative y-axis. It would be good to have this one as well. And so this is pi, up to here is 2 pi, and then we're going to come back in here would be 3 pi. So this is the angle 3 pi, and then 1 and then 2. So the point 2 and 3 pi is right there. Okay, so let me give you a small note, is that the first note is this one. R and 0 is basically the origin for all r, for all the numbers r. For example, 1 and 0 would be the origin because the angle is 0. 2 and 0 is the origin, 3 and 0, everything. For all r, if we have the angle 0, by convention we say that it's origin. And 2 is that we normally should always have r greater than or 0. Because of what? Because r is the distance from the point to the origin, so r should be positive. But sometimes we really need r to be negative for some curves or anything, so we need to have a convention for r negative. So I'm gonna say that if r is positive, the point lies on the same quadrant as theta. So this is the usual way that we show the point. Okay, when r is positive, we're just gonna start from the positive x-axis, and then we're just gonna count the theta. We're just gonna measure the theta, and then we have the r. But if r is negative, by convention, we're gonna say that the point is on the opposite side of the origin. What do I mean by that? I mean, negative r and theta is the same as r and theta plus pi. So basically, I'm going to say that if this is the positive x-axis, okay, and then if we have the point r and theta in here, if this is theta, we're gonna go the same size on here. This distance is also r, but this angle in here is theta plus pi. So the point that we have in here is the point r and theta plus pi, which is the point negative r and theta. Okay, so as you see that the point r and theta is here, the point negative r and theta is here. Let me show it to you some examples so that it makes more sense. If we're gonna show the point negative 1 and pi over 4, where is this? Okay, this is x-axis, this is y-axis. I'm gonna say that the point negative 1 and 4, it would be the point 1 and pi over 4 plus pi. Okay, so this is pi over 4, this is pi over 4, and for example, this length is 1. Okay, from here to here is 1. I'm gonna go to pi over 4 plus pi. It would be on the opposite side of the origin. You see, this point in here is 1 and pi over 4. This point in here is negative 1 and pi over 4. Okay, that's the difference between these 2 points. It's just because r is negative, and then by convention, we are going to show the point like that. How about if we have something like this? If we have negative 1 and 5 pi over 4, where is this point? Let's see. X-axis, y-axis. Let me bring the whole thing a little up so I have more space. Okay, so I'm gonna say that I'm gonna have, this is pi over 4. The whole thing in here would be 5 pi over 4. Okay, so 5 pi over 4 would be here. 5 pi over 4. But I have a negative r, so this point would be the same as the point 1 and 5 pi over 4 plus pi. You see, it's just because I want to make it on the opposite side, which would be what? Which would be 1 and 2 pi plus pi over 4. You see? So the point would be here. If this length is 1, this point is the point negative 1 and 5 pi over 4. It's just because it would be the same as the point 1 and 2 pi plus pi over 4. Okay? So every time that we have a negative r, we're going to just basically flip the point to the opposite side of the r. And if I want to show, this is the point 1 and 5 pi over 4. It's just because r is negative, we flip it on the other side. Okay, very good. Now the question is this: how to go from Cartesian to polar or vice versa. From polar to Cartesian, xy Cartesian, I'm gonna do this transformation. X would be, I'm gonna find x. X would be r cosine theta, and y would be r sine theta. Why is that? It's just because of this. You see, I have x-axis, I have y-axis, and just assume that this is the point r and theta that is given. So this length is r from the origin, the distance from the point to the origin is that, and then I have theta in here. So I have a right triangle in here. This length would be the x coordinate of this point. This length would be the y coordinate of this point. And using trigonometry, I know that this side in here would be r sine theta, and then this side in here, which would be the x, would be r cosine theta, to get the same point in the Cartesian. And from Cartesian to polar, I need to do what? R is square root of x squared plus y squared. It's just because x and y are given, and I would like to find r and theta. So r would be that, and then I need to find theta. What is theta? Look at here. The cosine of theta, and here would be what? Would be the adjacent side, which would be x over hypotenuse, and then sine theta would be y over r. Okay, so if I divide these two, I get what? I get tan of theta is what? It would be y over x. Why is that? Because tan is sine theta over cosine theta. Sine theta is y over r. Cosine theta, it would be x over r. So when I cancel 1 over r on the both top and bottom, I get y over x, which would be here. Okay, so let me give you one example. Example is this. What is -1 and 1 in polar? Okay, so I'm given what? I'm given the Cartesian, and I would like to find the polar. So the polar r is equal to what? Square root of x squared plus y squared. So this is square root of 2, and tan of theta would be y over x. Okay, tan of theta is negative, so theta would be pi over 4 or 3 pi over 4. But which one is that? Pi over 4 or actually, oh no, not pi over 4. It's just because pi over 4, the tan of that would be positive. So it would be 3 pi over 4. Okay, so I have what? Let me have the full. This is x. Oops. This is x-axis. This is y-axis, and then the point -1 and 1 would be here. This is the point -1 and 1, and then you see, if I have a right triangle in here, this is 1, this is 1. That's why this length is root 2. Okay, so this is root 2. How about the angle? The angle would be pi over 2 plus pi over 4, which would be 3 pi over 4. Okay, the next example would be example. What is 3 and pi over 6 in Cartesian? So where's the point? Let me graph the point first. X-axis, y-axis, 1, 2, 3, and then so this is 3, and then I need to go along the circle of radius 3, but the angle would be pi over 6. So this angle is pi over 6. Along this circle, I get 3 and pi over 6. What is this point in Cartesian? So the x coordinate of the point is r cosine theta based on the information that we have, and the y coordinate would be r sine theta. So y would be r sine theta. R is 3 cosine of pi over 6, which is 3 times root 3 over 2. And then this is 3 sine of pi over 6. which is 3 times 1 over 2. Okay, so this point is 3 root 3 over 2 and 3 over 2. Okay, so that's how we can translate polar to Cartesian and Cartesian to polar. So these four equations are very important for polar coordinates. And in the next video, we're going to see how to transform curves into polar coordinates.